So if you're trying to stay ahead of the curve in AI development right now, and I mean really ahead, you probably realize pretty quickly that building just one single specialized agent, well, that's kind of the easy part now.
That's exactly right. That's the baseline. The true frontier, and this is where the real complexity and, frankly, the power lives, is building systems where multiple agents can actually work together.
Seamlessly, right, and efficiently.
Yes, seamlessly and
Yeah.
often completely autonomously. And the framework you choose to do that, it's not just a matter of preference anymore. It's a fundamental architectural decision that basically determines what your system can do and, maybe more importantly, what it can't do.
And since you, our listener, probably don't have time to wade through, all the documentation for every new tool that pops up.
Which is endless.
Exactly. We've taken your source material, which gives us the core design philosophies of the top 4 contenders, and we're giving you the ultimate shortcut. We really want you to walk away from this deep dive knowing instantly which tool is designed for which job.
Yeah, our mission today is to just distill the core functionality and the ideal use case for these 4 big ones: LangGraph, CrewAI, AutoGen, and MetaGPT. We're going to go beyond just the feature list and really dive into the foundational choice that makes each one unique.
Okay, let's unpack this. We are tackling LangGraph, CrewAI, AutoGen, and MetaGPT. We need to cut through the noise and figure out, for each one, what is its defining feature, architecturally speaking.
And the trade-off.
And the trade-off you, as the system designer, are making when you choose it.
Exactly. Because these frameworks, they all offer these unique, specialized capabilities for orchestrating the kinds of complex multi-agent systems that are really defining the next generation of automation. We're talking everything from dynamic research workflows to, well, full-scale business process transformation.
All right, let's start with the one that feels the most foundational, I guess, in how it structures the flow of information. That's LangGraph. When most people think about agent workflows, I think they imagine a straight line, a chain. Agent A does its thing, passes it to Agent B, who passes it to Agent C. But what was so striking in the sources about LangGraph is that the core idea isn't a chain at all, it's a graph.
That is the critical distinction. LangGraph is, it's essentially an extension of some earlier frameworks, but it introduces this concept of state machines and cyclable execution, which fundamentally changes how agents can interact. It's built from the ground up for graph-based agent systems.
Okay, but why does that matter so much? Why move from a simple chain to a much more complex-sounding graph?
Because a linear chain is great for a fixed set of steps, but, AI tasks hardly ever run that way in the real world. Think about writing code.
Okay.
You write some code, you compile it, you test it. If the test fails, you don't just move on to deployment, right?
No, you go back and fix the code.
Exactly. You loop back to the writing phase. A graph structure is what allows for that. It introduces loops, conditional branching, and this dynamic decision-making on where to send the output next.
So it handles complexity by letting agents, revisit previous steps, or even pivot completely based on some intermediate result.
Precisely. And unlocking that unlocks 2 critical high-performance capabilities that linear systems just can't handle well. First, true parallel execution, and second, really robust real-time memory and state management. You define your goals, you create your agent nodes, and then you use the graph to manage the state as information moves simultaneously through different branches.
Wait, if LangGraph allows for all this concurrent execution, running tasks in parallel, doesn't that make managing memory and state exponentially harder? How does it solve that problem?
Well, that's the trade-off, right? It's definitely more complex to set up at first, but the graph structure forces you to define these very clear state checkpoints. The whole framework is built around managing an application state that gets updated as different nodes run.
I see.
This lets the system pause, reflect, and route the workflow conditionally. Or, and this is crucial, it allows it to recover if one path fails without losing the entire context of everything else happening in parallel.
Can you give us a quick use case? What kind of project just screams, you have to use LangGraph for this?
Oh, a dynamic research process, definitely. Imagine you task a system with creating a new business strategy.
Okay.
Agent A generates the raw idea. The graph immediately sends that idea at the same time to Agent B, let's call it the critique agent, and Agent C, the market research agent.
Right, in parallel.
In parallel. If the critique agent finds a major flaw, boom, the flow loops right back to Agent A with that feedback. But if the market research agent comes back with strong data, the flow proceeds to a different agent, maybe Agent D, the document generation agent. It's a self-correcting nonlinear machine.
So the key takeaway for you, the listener, is if your project needs these highly dynamic workflows, where you have iteration, complex logic, or you need to run things at the same time to maximize speed. LangGraph provides that foundational self-correcting structure.
Okay, now let's pivot a bit. We've talked about structure. Let's talk about interaction and teamwork. If LangGraph is all about maximizing internal speed through its structure, the next two frameworks we're looking at, Crew AI and AutoGen, are all about maximizing collaboration.
Yeah, and communication. But they approach that whole team dynamic from two fundamentally different places.
Right. It feels like we're moving from the architecture of the internal workflow to the architecture of the external conversation.
That's a great way to put it. I like to think of this as deciding whether you want a system that's, let's say, tightly choreographed and predictable, or one that's more self-adapting and emergent.
Let's start with the first one, the choreography, Crew AI. The source material calls this a dedicated collaboration framework. Collaboration is a pretty broad term, though. What does Crew AI actually prioritize? It prioritizes synchronization and roles. Crew AI is built for projects that require agents to work together, but in a very specific, controlled, and defined way. It's that tight choreography we were just talking about. Its power is in the orchestration mechanism, which is all driven by predefined roles, specific tasks, and a centralized process manager.
Almost like a production line supervisor.
Exactly like that. You, the human, you define the whole project scope. Then you assign these very specific specialized roles to each agent. You have a researcher, a reviewer, an editor. And these roles are given super clear goals and communication boundaries. The framework orchestrates the workflow to make sure the agents only talk within the lines you've drawn, synchronizing their efforts for better and more traceable decision-making.
So if I needed to, say, create a high-stakes document where I absolutely have to know who reviewed what section and one for compliance or something, Crew AI gives me that structured accountability.
Absolutely. The human sets the stage, defines the rules of the conversation, and that ensures synchronization. It really limits the freelancing behavior that agents can sometimes get into.
Okay, now let's flip the script completely. If Crew AI is about that tight control, then AutoGen, which is described as an automated communication framework, sounds like the total opposite. What's the crucial distinction?
The distinction is autonomy versus orchestration. So while Crew AI relies on you to define the roles and the steps, AutoGen is built on the idea of peer-to-peer communication. You give the agents a high-level goal, and then they autonomously generate instructions and coordinate with each other through this really sophisticated chat mechanism.
So the agents are actually talking back and forth to figure out the plan themselves without a central supervisor.
That is the core feature. AutoGen is fantastic for systems that have to interact with and adapt to dynamic environments with very little human intervention. The agents are basically in a group chat, arguing, negotiating, and figuring things out as they go. They don't need a central choreographer.
That flexibility sounds like a double-edged sword, though. If they're just talking amongst themselves, doesn't that sacrifice predictability?
It does, and that is the trade-off, 100%. With Crew AI, you gain predictability, you gain traceability, and you get synchronized output. But you sacrifice the ability for agents to, creatively pivot based on some unexpected breakthrough in their conversation.
And with AutoGen?
With AutoGen, you get that dynamic adaptation, that rapid, emergent problem solving. But you give up some of that tight synchronized control and the guaranteed structure of the output.
So to connect this back for the listener,
the choice comes down to how much control and auditability you really need. Do you need tightly choreographed synchronization where you define the roles in the flow? That's Crew AI. Or do you need self-adapting autonomy where the agents handle the conversation and adaptation themselves? That's AutoGen. Both are powerful, just totally different paradigms.
That comparison really makes the difference between synchronization and autonomy super clear. So let's shift the scale now, dramatically. We've covered dynamic workflows, small group coordination. But what if your goal isn't just a single project, but automating an entire department, an enterprise-level process?
Right. And that brings us to MetaGPT.
Exactly.
When you look at LangGraph, Crew AI, and AutoGen, they are, for the most part, focused on execution efficiency and agent interaction. MetaGPT takes a huge leap in scope. This is the framework where the goals shift from efficient collaboration to, comprehensive, scalable, organizational automation.
The sources really position MetaGPT as the enterprise solution. What does that architecture even look like? How is it different from just, running 50 Crew AI agents?
It's completely different. MetaGPT is specifically designed to create enterprise-level autonomous AI systems that actually mimic an organizational structure. It doesn't just manage a task flow. It internalizes what we call standard operating procedures, or SOPs. It can simulate a whole software company, complete with product managers, engineers, and QA specialists, all working against a defined process.
So if you give it a prompt like build a simple web scraper, it doesn't just come back with the code, it comes back with the entire project artifact package.
Precisely. That is the genius of its value proposition. Its function is centered on applying automated behavior and multi-agent collaboration to formalized business outputs. It automates these really specific high-value enterprise functions, including complex decision-making, creating formal, structured documentation,
Like what kind of docs?
design docs, API specifications, marketing briefs, you name it, and comprehensive task management across a whole simulated team.
Here's where it gets really interesting. If it's generating formal documents and automating task management, isn't there a risk of just creating operational bureaucracy at light speed? Where's the human sanity check in a system built for that kind of scale?
That is a very valid critique. The scale of MetaGPT means the human input has to shift entirely. Instead of supervising the agents task by task, the human focuses on defining the enterprise policies and the system requirements.
The constraints.
Exactly, the constraints within which the whole automated process has to operate. The framework is designed to output compliance and structure by design, because its internal agents are operating under these highly formalized, simulated roles. It provides a comprehensive framework for building scalable AI applications that are predictable at a corporate level.
So the goal isn't a quick prototype, it's operational transformation. If your project involves moving big, standardized business processes onto an agent system, processes that demand rigorous, formal documentation, MetaGPT provides that structure.
It's the difference between buying a set of power tools, which would be LangGraph, Crew AI, or Autogen,
Right.
and buying a prefabricated, highly configurable automated factory. That's MetaGPT.
Okay, let's bring this home. A quick synthesis. We've basically just given you the architectural cheat sheet for the 4 main frameworks in agent development right now. Let's recap. 1, LangGraph. That's all about graph-based structure for iteration, complex logic, and parallel execution. It's for dynamic workflows.
Perfect.
2, Crew AI. This emphasizes collaborative orchestration. It uses defined roles, tight synchronization. It's for accountable, controlled teamwork.
Right.
3, Autogen. This prioritizes autonomous communication, letting agents self-adapt and emerge with solutions through peer-to-peer chat. It's for your flexible, exploratory tasks.
Yep.
And finally, 4, MetaGPT. This handles enterprise scalability. It offers comprehensive automation by mimicking organizational structures and enforcing document creation and process standardization.
That overview perfectly summarizes the architectural decisions. And the central guidance from the source material is crystal clear. Your choice depends entirely on your project's main pain point. If your biggest worry is making tasks run simultaneously, you look at LangGraph. If it's auditability and control, you look at Crew AI.
If you need max adaptability, it's Autogen.
And if you need to automate a whole standardized business unit, you look at MetaGPT. There's a framework tailored for pretty much every requirement.
So these aren't really competing technologies in the classic sense. They're specialized tools for different outcomes. Understanding that foundational architecture graph versus synchronous versus autonomous versus enterprise structure, that's the key to making the right choice. And that brings us to the end of our deep dive, but we always like to leave you with one final thought to explore on your own.
This raises an important question. We just spent the last few minutes talking about how MetaGPT automates these really high-stakes functions, like complex decision-making and formal document creation at an enterprise level. So if these frameworks are getting so effective at automating communication and organizational processes, the next major challenge for you, for the learner to explore, is defining the optimal governance mechanism for them. Specifically, how do we verify alignment? How do we ensure regulatory compliance when all this coordination, decision-making, and even documentation is happening with no immediate human oversight?
Wow.
We have the frameworks for execution now. The future is going to require frameworks for trust.
A fascinating problem that sits right on top of this entire new technology stack. Thank you for joining us for this deep dive into the 4 leading AI agent frameworks. We hope this helps you choose the right tool for your next transformation.